Hi, this is Pratik and welcome to CodePy. In this video lesson, we'll learn about PostOrder traversal in a binary tree. Now we will be doing PostOrder traversal of this given binary tree with elements with nodes having data 1, 2, 3, 4 and 5. So there are 5 nodes in this binary tree, and the rule that we're going to follow is first go to left subtree, then right subtree, and then print the root. Now suppose that if we were to apply this rule on the simple given binary tree, then first we'll go to the left subtree, that is we'll go to 2, and when we move to 2 we'll be again applying the same rule. So when we move to 2, 2's left is none and 2's right is also none. Therefore we cannot move to the left of 2 and neither can we move to the right of 2, which means it's time to print the root, which means 2 gets printed. Then after we are done with printing the left part of this tree, which means now we have to go to the right subtree, which is 3. Again we apply the same rule at 3, which is left, right and print root. Now 3's left and right are also none, which means we cannot further travel down below to 3, and therefore now it's time to print the root of this subtree, that is 3. Now once we are done with the left and right subtrees of this entire binary tree, which means now it's time to print the root of this entire binary tree, which is 1. So this is how basically you can apply this rule, and this rule will be followed while we do PostOrder traversal of this binary tree also. Now when we apply the same logic over here, we see that the PostOrder traversed nodes are 4, 5, 2, 3 and 1. So now let's code this out. So first of all, I will have to define the basic structure of the nodes. That is, initially when a node is formed, you need to specify the data that you want to put in the data part of the node, and also the left and right part of the initially formed node should be none. So I define a class node, and inside this class node I'm going to define a constructor, and in this constructor I'm going to pass the node data. So whenever we will be forming the binary tree, so remember that we have not yet formed the binary tree to do PostOrder traversal, we will be forming binary tree, and when we form the binary tree we need to take help of this class node. How? That is, we're gonna see. So first we'll create an object of the class node in the main. We'll do that later, but for now understand that when we create the object of the class node and this constructor will be called automatically, then we need to pass the node data while creating that object. And when we pass this node data while creating the object, we need to mention that we need to put this node data into the data part of the newly created node. And as I said, newly created node is not linked to any other node, which means its left and right parts are none. So here none means they are not linked to any other nodes. Now before proceeding any further, I have to make the binary tree. So first I'm going to define a root equals node 1. So here root is basically serving as the object of the class node. So see here that I pass the node data 1. So the root is having the node with data as 1. So 1 goes here, and then it is placed as self.data, and its left and right parts are also none and none. So but if you see the overall structure of the binary tree, then find that 2's to 1's left is the node with data as 2, and to 1's right is the node with data as 3, which means initially when we form the node with data as 1, its left and right are none and none. So we need to change that none so that 1's left points to 2 and 1's right points to 3. So first I will be changing root's left. So I'm going to say root.left is equal to the node with data as 2. So here root.left serves as the object of the class node, and again this class node is used to make a newly formed node having data as 2, and that will be attached to root's left. So here root is the node with data as 1. Now similarly I have to mention root's right with a node as data as 3, and similarly root.left should have node with data as 4. So root.left is node with data as 2, which means 2's left will contain a node with data as 4, and similarly 2's right should contain a node with data as 5. So for that I'm gonna write root.left.right is equals node with data as 5. Now once we have made this binary tree, now it's time to do PostOrder traversal of this created binary tree. So for this purpose I am going to define a function called PostOrder, and I'm going to pass the root the root of the entire binary tree which I want to do post order traversal. So first I am going to check that if the past root is none or not. So here you can also write if root is not none. So basically both mean the same. So first I'm checking if root is not none, which means seriously a root of a binary tree has been passed in this post order function. Then first we have to traverse the left subtree. So first I am gonna recursively call this function, and I'm gonna call this function having parameter as root dot left. So when this innermost function runs and it takes the root parameter as root dot left, so when this function again runs, it will run from beginning, it will check if root, so here root will become root dot left. So if root dot left is not none, it's again gonna call itself recursively, and there will come a point when it will not be able to go to further left, and when it won't be able to go to further left, it will have to go to its right, and then finally print the root's data. So we're gonna see how all this function works step by step. So the first time the post of the function is called in the main, so each block represents a function call. So the first time it's called in the main, then the parameter passed to it is the node with data as 2 as 1. So first it checks whether the parameter passed is none or not. So here it is not none, which means now it recursively calls itself, and this time the root parameter that is passed to it is the node with data as 2. Now again this innermost function runs from the beginning and checks if the root parameter passed to it is none or not. So here again it is not none, which means again it's going to recursively call itself, and this time pass 2's left as the parameter. Now again this innermost function runs from the beginning, and when it runs from the beginning it checks if root, yes, it is not none. Then again it recursively calls itself, and this time passes root's left. So the root is now 4, root parameter is 4, and 4's left is none. So none will be passed as the parameter. So here in this function it recursively calls itself, but this time none is passed as a parameter. So when none is passed as the parameter, then this innermost function first performs the if statement's execution. So it checks if root, so root parameter is none. So since the root parameter is none, so all these 3 steps are not gonna execute. So when these 3 steps do not execute, which means the function is finished, it's done with itself. So when this innermost function is done with itself, it returns its authority to its upper function. Now in this upper function, with parameter as the node with data as 4, it sees that it has already executed the first step, which means it's time that it executes its second step. That is, it will again recursively call itself, and this time pass 4's right as the parameter. But remember that 4's right is none. Therefore, here also a recursive call will happen, and this time also none will be passed as the parameter. Again, the story will happen the same as happened with this function. So again, this function will return the authority back to its upper caller function. Now we are back inside this function, and in this function it sees that it has already executed the first step and second step, which means it's time to execute the third step, which is printing the root's data. So here the root parameter is the node with data as 4, which means 4 will be printed. So 4 gets printed out. So when 4 gets printed out, it sees that it has executed all its 3 steps, which means it has finished executing all its steps and it is done with itself, which means now this function returns its authority to its upper caller function. Now back to this upper caller function with the parameter as the node with data as 2, it sees that it has executed its first step, which means it will now execute its second step, that is recursively calling itself, and this time passing root's right, that is the node with data as 2's right, which is 5. So 5 will be passed as the parameter. So see, story is same with 5 again. So when the function having the node with data as 5 as the parameter, then that function runs, and first it checks if the node parameter that is passed to it is none or not. So here it is not none, which means now it executes the first step, that is recursively calling itself again and passing its left part. And when that happens, it again gonna pass none as the parameter. So when none is the pass as parameter, then which means the function steps do not execute, and it simply returns its authority to its upper caller function. And back to this upper caller function, it again recursively calls itself, and this time passes 5s right as the parameter to that recursively called function. So again, none is passed as parameter, and the story is the same. It returns its authority back to its upper caller function. Now in this upper caller function, it sees that it has executed its first step, second step, and which means now it will execute its third step, that is printing its parameters data, which is 5. So 5 gets printed out. So when 5 gets printed out, the function sees that it has executed all the steps mentioned under it, which means now it will return its authority back to its upper caller function. Now when we're back to this upper caller function, having the node with data as 2 as the parameter, now this function sees that it has executed the first step and the second step, which means now it will execute its third step, that is printing its parameters data. So therefore in this function, 2 gets printed out. Now when 2 gets printed out, it sees that it has executed all its steps, which means now it will return its authority back to its upper caller function. Now in this upper caller function with parameter as the node with data as 1, it again says that it has executed its first step, which means now it will execute its second step, that is it will recursively call itself again, in this time pass once right as the parameter. So when this function runs, it runs from the beginning, and it's going to execute all these 3 steps. So first it's going to execute its first step, that is recursively call itself, and this time pass 3's left, that is none as the parameter. So this function recursively calls itself and passes none as the parameter. So the story goes on same as happened with this and this and this. So it will return back its authority to its upper caller function, and when we are back at this function, it sees that it has executed its first step, which means now it will execute its second step, and this time again it will recursively gonna call itself, and this time it's gonna pass none as the parameter. So story goes on same, and it will again return its authority back to its upper caller function. Now back to this upper caller function, it has executed the first step, second step, which means now it will simply print its data. So 3 gets printed out. So when 3 gets printed out, this function sees that it has executed all its steps, so therefore it will return its authority back to its upper caller function. Now back to this upper caller function, it will simply print its parameters data, and then this function sees that it has also executed all its 3 steps, which means it is finished and it has done with itself, which means the overall function execution is over, and the printed output is in the sequence 4, 5, 2, 3, and 1. So let's call this post order function in the main. So I'm going to call this here, and I'm going to say post order, and I'm going to pass the root itself, the root of the entire binary tree that I formed here. So I'm going to save this program, and I am going to run it. So let's see. So yeah, so 4, 5, 2, 3, 1 gets printed in sequence. So this is what we wanted. So this is how post order traversal is done in the binary tree. I hope that you like the video. Please like and share this video and subscribe to the channel. Thanks for watching.